Is tomorrow just a ticking hand on a clock? Or is it a mystery that unlocks the doors of the universe? Today, we dive into the deep ocean of time, where every second holds the history of billions of years. I'm Eve, and you're watching Tales by Eve, where stories are different and truths are astonishing. What is time, really? Time. A ticking clock or the soul of the universe? Time. We all live within it. The hands of the clock move. The sun rises and sets. But have you ever truly wondered? What is time, really? Is it just a number, a calendar, a memory? Or is it something without which the universe would make no sense at all? Throughout the history of science, many great minds have questioned time. But Stephen Hawking was one of the rare few who dared to go deep into its very core. Today begins our unique journey, a quest to understand the origin, nature, and future of time. It's a story where the characters are you and me, and the stage, the entire universe. We want to know, how does time control our lives? How deeply is time woven into our very existence? Imagine you could go back in time. Would you? If you could know the future, would you want to? Does time really flow? Or are we just trapped in the illusion of clocks we made ourselves? That was just the beginning. Ahead lie gravity, black holes, relativity, and the science of imagination. So stay with us in this brief history of time from Tales by Eve. If you want to join this mysterious journey through time, then hit like, subscribe, and the bell icon. Because up next, we'll explore. Who was Stephen Hawking? And why was he so obsessed with time? Chapter 1. Time. A ticking clock or the soul of the universe. And today I'm taking you on a journey where there are more questions than answers, but within every haze hides a spark of wonder. Time. We live inside it, breathe through it, dream within it. Our birth, our death, our love, fleeting joys, deep sighs. Everything is tied to time. But have you ever paused for a moment to ask yourself, what is time really? As a child, I used to ask a question. Mum, what is tomorrow? And she would say, whatever hasn't happened today, that's tomorrow. But if today never came, how could tomorrow even exist? From that thought, a shadow took shape in my mind. The shadow of time, sometimes long, sometimes faint, sometimes sharp, sometimes blurry. But once it enters your consciousness, you can never think the same way again. I know you wear a watch. Minutes, seconds, days, months, years. You track them all. But think for a moment. If that watch were to stop, would time stop too? No, time would keep flowing. But perhaps the time we measure would fall apart. Stephen Hawking, a great scientist who, though confined to a chair, dove deep into the mysteries of time. He once said, time is not an absolute. It's relative. Time doesn't touch everyone the same way. We all experience it differently. When we fall in love, time seems to fly. But a night full of sorrow can feel like a lifetime. So, is this feeling what time is? Or is there a complex science hiding behind it? In this series, I'll tell you the story of time. A story that goes beyond the ticking hands of a clock. One that touches our existence, our universe, and even the future. We'll begin right from the very start. A time when there was nothing. No light, no sound, no time. Only emptiness. Then came the explosion. A moment when time took its very first breath. But that's a story for the next chapter. For now, just know. Time is a river whose flow you cannot stop. You can only look at it and wonder, where did you come from? And where are you going? And this was the beginning of the story of time. You can only look at it and wonder, where did you come from? And where are you going? Our relationship with time is just like that, invisible, yet all-encompassing, as if you're floating underwater, unaware of which way the current flows, yet somehow it takes you somewhere. Time builds us and it breaks us. Time teaches us that everything has its moment. A moment to be born, to wait, to love, to say goodbye, and to understand. I feel, before we can ever grasp the true form of time, we ourselves become part of its story. Temporary, yet essential. And I hear the silent sound of time. Do you hear it too? Stephen Hawking, a mental warrior in the galaxy of time. He sat in a chair, not blinking, but racing to the edge of time itself through the speed of thought. His body slowly came to a halt, but his mind raced faster than light. I'm Eve, and you're watching Tales by Eve, where stories are different and truths are astonishing. Chapter 2. He was a scientist. No, calling him just a scientist wouldn't do him justice. He was a soldier of time. Stephen Hawking, a man whose voice fell silent, but whose thoughts roared through every corner of the universe. A child born on a cold January day in 1942, who later said, "If the universe is a book, I want to read its last page." But the journey wasn't easy. At the age of 21, doctors said, "You have only 2 years left. You will die, fade, disappear." But what a wonder. He didn't give up. Even though his body gave in, his mind became the grammarian of time and space. He showed us time is not just a straight line. It's a curve that bends itself, creating doors of infinite possibilities at every turn. Stephen once said in his computerized voice, "However bad life may seem, there is always something you can do and succeed at." He taught us, the harder life gets, the higher it rises against the current of time. I am Eve, and today, standing at the door of time, I say, the body may restrain movement, but no force can stop the speed of a thinker's mind. Stephen Hawking was that speed, a cosmic warrior, whose story doesn't end here. Rather, this is the door, and when you open it, you don't just see time with your eyes. You feel it in your consciousness. We're heading deeper, to the place where time was born from an explosion, a magnificent birth that started it all. Chapter 3. The Big Bang. From nothing came everything. In the beginning, there was nothing. No light, no sound, no space, no time. Only emptiness, silent, still, and invisible. And then, suddenly, an explosion, but not a fiery destruction, rather, a miraculous birth. In a single moment, it gave rise to space, time, energy, and matter, what we now call the Big Bang. The Big Bang wasn't a sound, it wasn't something you could hear. It was the first pulse of time, a vibration that couldn't be heard, yet whose shock waves spread across the universe. There were no stars, no galaxies, not even light. Only a wild, scorching fireball, inflating unimaginably within a fraction of a second. Imagine standing at a single point. The moment time itself has just begun. You witness particles being born, energy transforming into matter, light piercing through the void. An unbelievable act of creation. With no blueprint, no architect, yet forming rules, structure, and beauty with perfect balance. And that is how time was born. A race had begun, one that has never stopped. Science says the Big Bang happened about 13.8 billion years ago, which means everything we see now, the stars in the sky, our Earth, even you and me, all trace back to that very moment. Just think, one moment where there was nothing. And from that nothingness came humans, thought, and love. And I believe that moment wasn't an explosion, but rather the unveiling of a silent, invisible curtain, as if emptiness whispered, I want to become something. So, now, let us begin the next chapter of our story, where darkness is pierced and the very first light is born. Chapter 4. First Light. How did light emerge from darkness? The darkness was deep, so deep that even shadows didn't exist. Because without light, there can be no shadow, right? After the Big Bang, there was time and space, heat and energy too. But still, no light. It was as if everything was wrapped in smoke. A universe-wide fog where things were forming, yet nothing could be seen. This era of darkness is called the Cosmic Dark Age. A mysterious time when everything was silent, yet inside, preparation was underway. And then, much later, some hydrogen atoms began to come together. They embraced each other, and under pressure and heat, fusion began. And at that moment, the first light ignited. No, not the light of a bulb. This was the birth of a star, the first star of the cosmos, whose light touched the void for the very first time. The stars ignited, and their light traveled millions of light years across space. The fog cleared, and slowly, the universe began to reveal itself. That starlight still flows into our eyes today. When you look up at the night sky, what you see isn't just light, it's history. Because that light took billions of years to reach us. Which means, when you look at a star, you're actually looking into the past. Imagine a window in time opening before your eyes, where you can witness the very first breath of the universe. And I know, light doesn't just illuminate, it whispers, you exist, you were, you will be. And the story of that first light reminds us, no matter how deep the darkness is, light always finds its way. So now, let us begin the next chapter of our cosmic tale, where within galaxies, kingdoms of stars form, rivers of gas flow, and the possibility of life emerges. Chapter 5. Birth of Galaxies. The roar of the spiral giants. When you look up at the sky, you may see thousands of stars. But did you know? You're only seeing a tiny part of a galaxy. Stars aren't born alone in the universe. They are born in groups. They ignite together, revolve around a center, and slowly build one of the most magnificent structures in existence, the galaxy. A galaxy, a cosmic highway, where gas, dust, stars, black holes, all spin together in a grand celestial rhythm. In the beginning, clouds of gas and dust were scattered and chaotic, but gravity slowly pulled all particles inward. Inside, hot gas began to condense, and hundreds of stars were born. These massive star clusters began to spin, taking on specific shapes. Some spherical, some elliptical, and some spiral galaxies like our own Milky Way. Do you know what's at the center of almost every galaxy? A black hole. A terrifying well of gravity around which everything spins. Stars, gas, and even time. Imagine standing at the edge of a galaxy before you, more than 100 billion stars, all spinning together for billions of years. It's a strange kind of chaos, where there's no sound, yet there's motion, where there are explosions, but in silence, where birth and death are woven together in the quiet web of time. And in one such galaxy, many years later, a bluish planet will be born, the one we call Earth. But that's a story for another time. Today, just remember, you're not alone in this universe. You are cradled within a galaxy that's carrying you along in a mystical dance through eternity. And let me remind you, you are not just a body. You are a child of the galaxy, forged from stardust. You are a living cosmic history. Now let us descend into a tale of terrifying beauty.
Chapter 6. Black Holes, the Invisible Beasts of Gravity. You cannot see it. Light disappears inside it. Time stands still there, and matter seems to melt into an unknown, bottomless abyss. This is a black hole. When a star ends its life, it explodes in a catastrophic supernova. And if the star is massive enough, it collapses under the weight of its own gravity, shrinking into a point so dense where gravity is so strong, even light cannot escape. And that's when a black hole is born. Imagine a place where space and time curve and twist, where you feel as though you've entered the forgotten pages of a story where the end is not really the end. If you approach carefully, you'll see the event horizon, an invisible boundary beyond which there's no return. No light comes back, no message escapes. Everything vanishes in silence. Science tells us black holes don't just devour, they influence everything around them. Gas, stars, even entire galaxies dance to their pull. They are the invisible kings of the cosmos, ruling without a throne, yet everything obeys them. And imagine, this terrifying entity was first proposed by a human, John Michel, in 1783. Centuries later, we have proven their existence right at the heart of galaxies. A black hole is a fearsome poem, where death is not the end, but perhaps the beginning of another story. And I know, even if you disappear into the deepest darkness, your story does not end, because even the darkest corners of the universe hide a new beginning. So let's step into a chapter where people imagine turning the clock backward, where it's not memory, not the future, but time itself that asks, do you obey my rules, or will you change me? Chapter 7. Time travel. Is it really possible to go back? Time travel. A dream humanity has chased for ages. Imagine if you could go back to your childhood, or take a quick peek 100 years into the future. What does science say about this? Let's twist the clock a little and take a look. According to Einstein's theory of relativity, time isn't constant. It flows, bends, and can even change. Immense speed or massive gravity can pull on time, slow it down. If you move at a speed close to light, time will slow for you, and even if 10 years pass in the outside world, it might feel like just an hour to you. That's time dilation. So, is traveling to the future possible? Yes, at least science says so. But going back, that's where things get complicated. Going back, does it mean changing the past? And if the past changes, does the future collapse? Imagine you return to your childhood and don't save yourself from an accident. Then how did you survive to grow up? Who went back? This is the grandfather paradox, a mystery maze that makes time travel so baffling. But scientists haven't stopped. They say wormholes or time loops could one day be real. Imagine opening a door and finding two timelines on the other side. One is now, the other is the past. You step in, and the clock hands seem to walk backward. But the question remains, do we want to travel through time to gain knowledge, or just to erase our mistakes? I am Eve, and I know time is like a river, flowing in one direction, but if you dive deep enough, you might hear the quiet, hidden paths beneath it. Will you find those paths? Let's now face a question we've all thought about at least once. Does time only move forward, or is there a way to turn back? Chapter 8. The Arrow of Time. Is time a one-way road? Time always moves forward. Morning comes, night falls, trees grow, leaves fall. We are born, we grow, and one day, we go. It's so normal, we never ask, why doesn't time go backward? Scientists call this the arrow of time. This arrow always flies in one direction, toward the future. But why? The answer lies in entropy, a measure of disorder. Every system, every event naturally drifts toward more chaos. If an egg falls and breaks, have you ever seen it stitch itself back together? Time's arrow moves toward disorder, and that tells us time is one way. What's gone doesn't return. But here's the strange thing about physics. Its fundamental laws don't treat time as one way. If you reverse a molecule's motion, it can retrace its exact steps. So, is time just our perception? A mental illusion? Think, if all memories vanished, would you know what was yesterday or tomorrow? Time may not be a river, maybe it's a book with every page already written, and we are just flipping from one to the next. I am Eve, and I know time shows us a path forward, but maybe behind it lie countless unseen roads. And if time ever stops, remember, you haven't stopped. Because even when time pauses, the story goes on. Let's descend now into that mysterious moment where the calendar had no date, the clocks had no hands. There was no light, no dark. There was only a beginning. Chapter 9. The Beginning of Time. How did the first moment begin? If you turn the clock backward, pull time in reverse, you'll reach a point where there's nowhere else to go. In that one point lies the birth of time. This moment is what we call the Big Bang. Many think it was an explosion, but it was actually an expansion. From a single point, space, time, energy, and matter spread toward infinity. But what was before that? Now that's the question that shakes the very edge of human understanding. Because to say before assumes time exists. And if time began at the Big Bang, what does before even mean? This is where science stumbles and philosophy whispers, it's simply beyond us. Physicist Stephen Hawking once said, "If time has a beginning, it doesn't need a creator. It is its own cause." Imagine, the same clock of time that ticks forward today once ticked for the very first time. As if, in a divine darkness, a hand reached out and pressed start. And with that touch, the entire universe awakened. And I know, the beginning of time may not be a beginning at all, but a new question that forever haunts us. Why is there something instead of nothing? So now let's ask, this universe we call home, this infinite vastness, does it have an edge? Or is there even such a thing as an end? Chapter 10. The Boundaries of the Universe. How did everything get so big? Imagine standing at a single point. There's nothing around. No light, no sound, no horizon. Suddenly, that point starts expanding. In a fraction of a second, it becomes a giant ring. Then bigger and bigger. This is how our vast universe began, with a moment called inflation. Right after the Big Bang, the universe expanded faster than light. A microscopic point became the blueprint of everything we see. In just 10 to the negative 36 power seconds. Imagine, if you were there, right before your eyes, space, direction, time, motion, everything would be born. And today? The observable universe spans 93 billion light years in diameter, yet it's only 13.8 billion years old. How's that possible? Because space itself expanded. We didn't throw anything outward. The cosmos grew itself, as if space and time held hands in a cosmic dance. Now the question is, does it end somewhere? We don't know. We look as far as we can and wonder, what lies beyond that? Some scientists say the universe is infinitely large. Others say it's like a bubble, floating among many others, a multiverse. This is the multiverse hypothesis. You, me, our Earth might just be a tiny grain in this endless infinity. And yet we stand on this little grain, look up at the sky, and wonder, who am I? And I know, you might be small, but your imagination is just like the universe, limitless. So now, let us walk into a place where time halts, where the stars begin to fade one by one, and the universe itself may come to a long, cold silence. Chapter 11. The Fate of the Universe. Does everything have an end? There was a time when there was nothing. Then came the explosion, the Big Bang. Then came the stars, the galaxies, the planets, and you and me. But everything that begins, does it also end? That is today's question. Science says the universe is expanding. Every day, every moment. Galaxies are drifting apart. Slowly, yes, but relentlessly, and not just expanding, accelerating. But what's pushing this expansion? Its name, dark energy. A mysterious force that's driving the universe outward, and it just won't stop. So the next question, when will this motion end? Scientists say there are three possibilities. 1. The Big Freeze, the most widely accepted theory. The expansion continues forever, and one day, stars will burn out, Earth will grow cold, and the universe will become a silent graveyard. No light, no motion, only darkness. 2. The Big Crunch. Perhaps one day the expansion will stop, and everything will collapse back inward, pulled to a single point, just as it began, as if time itself will swallow its own flow. 3. The Big Rip. The most terrifying theory. If dark energy grows stronger, one day it could tear even atoms apart. Space itself would rip. Everything would shred like torn paper into nothingness. But we still don't know for sure which one will come true. And yet one thing is certain. This grand cosmic drama will have a final act. Maybe no one will be left to witness it. But the story, the wonder, we are still writing it today. And I know there is no such thing as an end, only a transformation of the story. The star that shines in your eyes today will one day fade, but its light will live on, in your story, in my words. So now, let's move to a chapter where time and space, two separate ideas, merge to create our reality, a complexity that seems simple to our eyes, but is actually a cosmic illusion. Chapter 12. Space and Time, How They Form Our Reality. Together. Right now, as you sit, you're surrounded by space. Rooms, skies, distance, height, they're all parts of it. And when you look at the clock, you know time is moving forward. Morning, afternoon, evening, night. But what if I told you? Space and time aren't separate things. What if I said, your movement, your weight, even your thoughts are actually bending space-time? This idea came from Albert Einstein. He proposed that space and time together form space-time, a four-dimensional fabric within which we exist. Imagine placing a heavy ball on a stretched blanket. The ball creates a dent. Now roll a marble nearby, and it spirals into that dent. That's how the sun bends space-time, and the Earth keeps orbiting in that curve. What we call gravity is actually the motion along that bend. As you move forward in time, you're carving a path through space-time. Here comes the wonder. If you move really fast, time slows down for you. If you're near a massive planet, time also slows down.
Change space. Time changes. Change time. Your reality changes. And yet, even with all we've learned, we still don't fully understand space-time. Because it's not just something to measure, it's something to feel. Where you are, how you live, your body, your mind, your soul. Everything is woven into the web of space-time. And I know the world you see with your eyes is not just a view, but a bend, a motion, a story. Not a story of time alone, but of space-time. And this story still unfolds. Now let's step into a deep, dark mystery, where even light cannot escape, where time comes to a halt and space loses its path. Chapter 13. Black Holes, where time and space collapse. Imagine you're looking at the sky. A star has burned for millions of years. Its light has just reached your eyes. But at some point, the star collapses under its own gravity. It doesn't simply fade, it becomes something else. Something from which not even light can return. Its name, black hole. A black hole is a place where mass is so dense and gravity so intense that anything, light, time, even information, once it enters, never escapes. Think of it. a place where the flow of time holds. If you could observe a black hole up close, you'd see time slowing down around it. And if you were to fall into one, time would stop. For you. Even if thousands of years pass in the outside world, you'd experience it as just a moment. That boundary is called the event horizon. Once crossed, there is no return. A cosmic trap of space and time. But did you know? Black holes don't just destroy, they give birth to new questions. Physicist Stephen Hawking once said, "Black holes aren't black, they glow." This glow is called Hawking radiation, which means black holes might slowly evaporate and disappear. Where time had once stopped, it might begin again. And the most astonishing idea, scientists now believe that maybe deep inside every black hole lies the doorway to another universe. A tunnel called a wormhole, a fold in space and time that could take you across the universe in an instant, or maybe even to another time. And I believe a black hole is not just an end, but a strange kind of beginning. Because where science stops, imagination begins to search. And on that path, maybe one day, you will walk, without light, carrying only your faith. Now, let's push open the door of time and step into a mysterious tunnel, a place that can fold time and space and take you across billions of light years in a moment. This is today's story. Chapter 14, Wormhole, the secret tunnel of time travel. Imagine you're holding a piece of paper. On one end is you, on the other, your future. To connect the two, you'd have to cross the full length of the paper. But what if you fold it? Now, the ends touch, and you've jumped across in an instant. From this idea was born one of the most fascinating theories, the wormhole. In Bangla, kitsurung, kitsurong. A wormhole is like a shortcut through space and time, a magical bridge built in the middle of the cosmic void. It's like the Meghna Bridge of the universe. But how is this possible? Einstein's theory of general relativity said space-time can bend, and that bending can create a tunnel. Einstein and Nathan Rosen called it the Einstein-Rosen Bridge. At one end of a wormhole could be you, and at the other, a faraway galaxy, or maybe your future self. So, is time travel really possible? According to theory, yes. If one end of a wormhole is moved at high speed, time slows down at that end. Thus, a time loop can be formed. But can we really go back to the past? Here's where it gets complicated. Because time travel brings paradoxes. Like, if you go back in time and stop your grandfather from meeting your grandmother, how were you ever born? This is called the grandfather paradox. Science still doesn't know if wormholes can actually exist. They require extreme stability and negative energy, which we currently can't produce. But in our imagination, that tunnel's door is still open. A day may come when we won't need rockets, but we'll travel through wormholes across time itself. And I know, the world you think binds you is only one path. Beyond it lies infinity. And with the key of imagination, you may one day unlock the gateway to time travel. Now, let's enter the oldest dream of humankind, where we want to return to the past, see the future, and ask the eternal question: is time a one-way street? Chapter 15, Time Travel, Science Fiction or the Future of Science. When you were younger, you probably thought, if only I knew tomorrow's exam questions today. Or, if I could just go back and fix that one mistake. This longing, this curiosity, gave rise to one of the most thrilling ideas in human history: time travel. But is time something that only moves forward? Or can it go back too? Einstein said time moves together with space. If you move very fast, nearly at the speed of light, time slows down for you. This is called time dilation. For example, if you travel through space at light speed and return after 1 hour, 100 years might have passed on Earth. This is not fiction. This is science. But that's travel to the future. What about the past? Now it gets complicated. Wormholes, cosmic strings. Theories exist that suggest one day we might travel back in time. But time's biggest enemy is paradox. If you stop your own birth in the past, then how did you go back at all? These contradictions stop science in its tracks. Stephen Hawking once said, "If time travel were possible, we'd already have visitors from the future. But no one has come. So does that mean time travel is impossible? Not necessarily. But it's very, very hard. To bend time, we need infinite energy, negative energy, and technologies far beyond today's limits. But remember, airplanes were once science fiction. Mobile phones were once impossible. So maybe one day, your grandchildren will ride time machines to the Renaissance, or come back to your childhood. And I believe, time travel is still a question today, but one day it might become humanity's greatest answer. And you might be the one who steps into the past for the very first time. Now, let me introduce you to the great scientist who reshaped our understanding of time, gravity, and black holes, and changed the direction of science across the entire world. Chapter 16. Stephen Hawking, the man who redefined time. On a cold night in 1942, a boy was born, Stephen Hawking. From early childhood, he showed signs of an exceptional curiosity. But fate had prepared a brutal trial for him. Stephen was struck by a rare disease, ALS, which slowly paralyzed his body. Yet his mind remained sharp, and his spirit was unbreakable. Stephen Hawking was the man who took the most complex questions of the cosmos and tried to explain them in the simplest of words, becoming a legend in doing so. He was the first to propose that black holes emit radiation, what we now call Hawking radiation. It was a revolution. Until then, we believed black holes only grew, swallowing everything with no return. But Hawking showed us otherwise, that black holes too can decay. His work didn't just change science, it changed the way humanity thinks about the universe. Stephen once said, "To understand how time works is to understand the heart of the universe." He authored many books, touching the minds of millions across the world. His life was a constant battle. He couldn't even rise from his chair. Yet his thoughts soared beyond galaxies and reached into the darkest corners of the universe. And I know Stephen Hawking taught us that true strength comes from the mind. And the mind, when truly free, can even defeat time itself. Now, let us begin the story of that one explosion, that moment which gave birth to our entire universe and still keeps scientists searching for answers. Chapter 17. The Cosmic Explosion. The deep mystery of the Big Bang. Imagine a tiny dot, infinitely small, where all of time, space, energy, and matter were compressed together. This dot was unimaginably dense, unimaginably hot. And then, in a single moment, it exploded. That was the Big Bang. The Big Bang marked the birth of our universe, the beginning of time itself, the expansion of space, and the creation of the very first particles of matter. Since that explosion, the universe has been expanding, and we still see proof of it today as galaxies race away from us. But the Big Bang remains wrapped in mystery. Why did it happen? Was there anything before it? Where does the edge of the universe lie? Scientists have proposed many theories. Some suggest the universe emerged from a strange state of quantum foam. Others believe we are part of an eternal cycle, an endless loop of births and deaths of universes. But the biggest question remains: was the Big Bang truly the beginning? Or was it the start of something, after an even bigger event? And I know, the more we seek to understand, the more the universe reveals new enigmas. The story of that explosion is only the beginning, and we are right in the middle of it, wandering through an endless journey, searching for answers. So now let's travel back in time, to when galaxies began forming, stars ignited for the first time, and eventually, our very own Earth was born. Chapter 18. The Structure of the Universe. Galaxies, Stars, and the Story of Planets. In the first few minutes after the Big Bang, elements like hydrogen and helium were formed. The universe was still blazing hot, too hot for particles to hold on to each other. But as time passed, it cooled down. And slowly, those gases condensed and began forming. Stars. A star is born inside massive clouds of gas, pulled inward by gravity, until at the core, a fire ignites, nuclear fusion. This fusion creates new elements: carbon, oxygen, iron, even gold. Which means you and I are made of stardust. Stars gather to form galaxies. Our galaxy, the Milky Way, is a cosmic city of over 100 billion stars. Around those stars orbit planets, moons, comets, and in some rare corners, perhaps life itself. Our solar system's sun is a middle-aged star, surrounded by Earth, Mars, Jupiter, and countless asteroids. But how did such a massive structure become so perfectly balanced? The answer lies in gravity, explained by Einstein's theory of relativity. Gravity doesn't just pull, it bends space and time. And in that curvature, galaxies, stars, and planets find their place. And so do you. And I know the universe is not just a collection of distant stars. It is our origin story, a vast yet precise structure, where we are each a tiny, meaningful part. Now, let us descend into one of humanity's oldest, most profound questions. Are we alone in the universe? Chapter 19. The Search for Life. Are we alone? You've surely looked up at the night sky and wondered, among these countless stars, these endless galaxies, why only us? In our Milky Way alone, there are about 100 billion stars. Many of those stars could have planets, and current research suggests there are over 300 million Earth-like planets in the habitable zone of just our galaxy. And the universe holds over 100 billion galaxies. So, then, are we really the only intelligent life? What does science say? In 1977, Voyager 1 was launched, a tiny spacecraft carrying a golden record, containing greetings, music, images, and messages from Earth. Just in case someone, somewhere finds it someday and knows there is life on Earth. There's also SETI, Search for Extraterrestrial Intelligence, which listens to the deep whispers of space using radio telescopes. In 1977, a mysterious signal was detected, the WOW signal. But since then, silence. So, are we truly alone? Many scientists believe that life doesn't happen just once. It could arise millions of times. Maybe that life doesn't look like us, maybe it floats in gas clouds, or thrives in extreme heat. And maybe they are also searching for us, just like we are searching for them. Stephen Hawking, once warned that even if extraterrestrial life exists, contacting them could be dangerous. They might not be friendly. They might be far more powerful. And I know the answer may arrive one day. Maybe a signal will float in from a distant star. Maybe we're not alone. Maybe we are part of someone else's alien story. This brings us to the final chapter, where, walking along the path of time, we arrive at the edge of the universe and face one last haunting question. Does it all come to an end? Chapter 20. The end of time, is the universe eternal, or will it die too? Imagine time as a river. We've learned how it began, at the Big Bang. But where does this river flow? Does it merge into an ocean, or vanish in a desert? Modern science tells us the universe is expanding. But not just expanding, it's accelerating. This discovery came from studying light from distant galaxies. And this expansion might lead the universe toward one of three possible endings. 1. Big freeze. The silent end. If expansion continues forever, galaxies will drift so far apart that light and energy won't reach from one to another. Stars will burn out. Planets will become frozen rocks. And the universe will fall into cold, lifeless darkness. 2. Big crunch, collapsing inward. If expansion slows and reverses, everything, matter, light, even time, could collapse back into a single point. A reverse explosion that might lead to a new Big Bang. A cosmic cycle of endless creation and destruction. 3. Big rip, tearing time apart. The most terrifying theory if expansion speeds up too fast. Even atomic bombs won't survive. Galaxies, stars, planets, everything will be torn apart. Even space and time will cease to exist. So what does the end look like? A silent, frozen death? Or a fiery rebirth? We don't know. But we do know this. We are still in the middle of time. On a tiny blue planet. As small creatures more. Who dare to look up and ask, where do I belong? I am Eve. And I know time is a story. We've learned its beginning. But its ending remains a mystery. And that's what makes time the most mysterious storyteller of all. You've been listening to Tales by Eve, where stories are different and truths are extraordinary. Thank you for joining us on this journey through the universe. Time will now carry you to another story. But that is a tale for another chapter.